Hi there, and welcome to this crash course on data wrangling with Python. This is a course that comes after the course, the crash course on Python basics for data science. And in this particular crash course, we are going to be covering various concepts with regards to data wrangling. We are going to be covering how to read data, how to perform data exploration, how to handle irrelevant data, how to handle duplicates, how to perform filtering and sorting, and also how to export data. So, in general, data wrangling is the process by which you would manipulate your data upon sourcing it from a particular data set, and you would prepare that data for further analysis. So it's a whole stage of data science uh, while you're working on projects that entails a set of different concepts, the application of a set of different concepts. So in this particular course, while we go through all these different concepts, it's highly encouraged that you also participate through the notebook that we're going to go through in the session itself. And the idea is that you would also be practicing along while I take you through. So upon finishing this crash course, you could continue and explore a full course that we have on data wrangling with Python that entails other different data wrangling concepts. In addition to that, there will be also challenges that will allow you to practice what you will have learned and put that into practice through challenges as well as a project at the very end. If you also have questions, you could always ask in the comment section, or you could also join the AfterWork data science community via the also link, the Telegram link that will be shown in the description link, and you can ask your question within that particular platform. So this course is tailored for beginners. So if you're a beginner, you're still okay, but be sure to have gone through the Python basics for data science crash course. That way, you are able to acquire the Python basics that are required for working on any sort of data science project before coming to this particular workshop. This particular crash course. All right, so we'll move now to the notebook environment that we're going to be using for this particular session. And if you're new to data science in general, a notebook environment is simply just an environment that allows you to put your analysis and share with other data science stakeholders. So you can think of a notebook as simply a document that contains all your analysis, whether it's in text form, pictorial form, or in code form. But the beauty with notebooks is that you can be able to run your code within that document. So the notebook that you can see on the screen can be accessed by following the practice notebook link at the very bottom of the description. And once you get here, the first thing that you're going to do is to make a copy of this notebook. So go file, then save a copy in Drive. So you just need a Google account to run this. Once you have saved a copy, then you can be able to make edits to your copy of document. So this document contains all the concepts, all the examples that we're going to be going through. So how I'm going to be doing this is that I'm just going to be explaining what are the different concepts as they pertain to data wrangling, and when exactly to use them, and how do you apply them using the Python programming language. All right, so the first thing, once we have our own copy, we need to connect our notebook to Google servers by hitting connect at the top right. Then once your notebook is connected, it usually takes a bit of some time depending on your internet speed, but maybe not more than even 30 seconds, 30 seconds on the high side. So once you have been able to connect, you can then be able to run the different sections. So the first thing that we do, we are going to work with two libraries. So a library, if this is your first time learning about libraries, you can think of a library as majorly a, a bunch of code that has been written and tested and can be reused by other persons. So, and libraries usually have a specific purpose. So in Python, there's a library for performing data manipulation, which is pandas, and that's the one that we're going to use. There's also NumPy, which provides you with scientific computations. So it provides you with functions that allow you to perform some complex scientific sort of calculations. So NumPy is also the other library that we're going to use. And as you go along in your data science journey, you'll get to work with other different libraries with their own specific purpose, like matplotlib for data visualization. We're going to actually go through that in a future course, crash course. There's also Seaborn for visualization, or scikit-learn for machine learning, and there are other many other libraries which we may not be able to exhaust if we were to talk about them in this crash course. So the first thing that we're going to do, because we're going to be working with now datasets, we're going to need pandas, and we're also going to need the NumPy library. So we're first going to import those two libraries. So how you import it is as shown in this line. So import then the library name and as PD. So any place that we use PD, we're actually referencing pandas. The same case, we import NumPy as shown, import NumPy as NP. Any place you see NP, we're actually using NumPy. So the first concept that we're going to be learning is how to read data. So data might be stored in different sources, in different locations, but in most cases, when it comes to working on data science problems, a common way of storing data is through the use of CSV files, and that is what we are going to majorly be using. However, you could also be able to store your files in Excel files and also in other different formats, or .sql, or different formats, but we're going to be using CSV files for this particular session. So we're going to learn how to read CSV files from your laptop locally, or from even a particular URL. So a CSV file could be stored in a particular URL. So you should be able to learn how to be able to read that using Python. So by reading, we'll be importing those files into our notebook environment for further analysis. So reading data. So assuming that we wanted to read a CSV file from this particular location, if you click on this location, or if you copy this location and paste it on our web address bar, it actually is going to download this particular file. It's an iris dataset. It's a common dataset in data science. So we're going to read this particular file. How we do that, we use pandas. So PD. So before that, we can see that we have df, which is it's a variable. But in pandas, what we're going to be doing is storing a table within that variable. When it's stored, it usually is referred to as a data frame. And a data frame is a two-dimensional data structure that is used to represent a table of data. So you can think of a data frame as just a table that has rows and columns. So we're going to be having the data frame name, which is df, and what we are going to be storing in it will be read from this location. So we use pandas pd, then the function read underscore csv, then we define the location of the file. So if I were to so once we have read the CSV, we will store it in DF, and then we can preview the first 5 records, just to make sure that we have actually been able to import that file. We can preview it using the .head function as shown here. So if I run this, I should be able to get okay, all right. So the problem here, if you get this error, it simply means that you need to import pandas. We haven't run these two cells, so import pandas. So run this cell to import pandas, and also run this to import numpy. So if we run this cell, you should be able to see the first 5 records of our data set, which are as shown. The first column is index column, so you wouldn't consider the first one, so you just consider 1, 2, 3, 4, and 5 columns. Now, from now on, we're going to be using the term variable to refer to a column. So I'm going to be mentioning, when I say we have, let's say, 4 variables or 5 variables, I actually mean the columns. It's the right term to use when you're working with regards to data science. But there are also other terms that you'll come to learn about, such as features and labels. Okay, so in this case, we have been able to load our dataset from a URL, but we can also load our dataset from a file that's stored locally within our laptop or your laptop by simply uploading the file to Google Collab and reading that file. So we can just visit this link, just follow the link, and it's going to download that particular file that we need. So it's going to download it, just waiting for a second or two. Once it has downloaded, it's going back, just waiting for it to download. Okay, let me just copy this link, paste it here. So it has downloaded it. It's cities, then it has renamed it as for have other cities files in my download folder. But we're going to use this to read the file. So once it has downloaded, you would go on the left side of Collab. There's a file icon. You click over there, and you would need to drag your file within this particular section. Don't drag it inside these folders, but drag it just somewhere here. Or you can use this particular icon over here, upload to session storage, or that's the first icon on the left below files name, to load that particular file. But in our case, we might want to just take it there. So I'm just going to drag my file there. And something to note is that if we were to close our tab, this particular tab, the Collab tab, it would mean that that particular file will be lost and we would need to re-upload it again. There are other ways that you can be able to also load your data set. You might upload it to Google Drive, but you need to also import a few things, like a few other libraries which would help you to read that particular file. So once we have our file in here, we can then read it by passing the name of the file to pandas, so to the read underscore CSV function, read CSV function. So in our case, our name of the file is cities, then there's a space in between. So if we read this, do note the difference. DF cities is a different data frame name than DF here. So if I were to run this, I would be able to get now our new data set. So, but if suppose you wanted to you had dragged this inside the sample data folder, so I'm going to drag it inside, then you would need to mention the directory sample data or that folder underscore data in while you're reading it. So if I run this again, by running it, you can just press that icon, the icon, top left icon, or you can just press Shift Enter. Then you should be able to see that you have been able to load your data set again. So it's still inside, it's just that it's in a directory or folder, which you can see cities underscore CSV. Okay, all right. So something to note, as had mentioned, in the full course that you'll find a link to below, you will be able to get some challenges that you can use to practice these two concepts. But if you're not interested in the full course, you can just use the practice notebook for your learning. All right. So the next thing that we're going to do is perform data exploration. So we're just going to explore our data by simply, so just to mention, the whole data science process is that normally you would source for data that's stored within a particular database. For that, you can use SQL. You need to learn how to do that with SQL. I'm also going to post a link with regards to SQL down there if you're interested in that crash course. You would need to learn about SQL and how you can be able to sort that. So once you have been able to source for data from an SQL database, you can save it as a .csv file. Then you can import it just the way that we have done in our notebook. Then once you import it, you can now perform data exploration techniques. We've actually performed a data exploration technique by using the .head method because we are exploring our data set by simply previewing the first 5 records just to get a feel, the story of our data set. Then once we so using the head function is one of the many data exploration techniques. So and that might involve just understanding how big is your data set, what are the data types. In the Python basics course, we covered data types, so you also get to learn how to be able to get to understand what are data types, what are the data types that what data types do our variables have. You can also be able to preview the last few records. You can also be able to do a statistical summary of your entire dataset record. So so data exploration majorly entails performing an initial data analysis in order to understand the data set that you have. So the next section covers a few data exploration techniques. So if you wanted to determine the number of records in the data set, we can use the .shape property, and this will return the number of records, comma, the number of variables. So if I run this, so df is the first data set that we had here. So that's the iris data set. So if I run this, I should be able to get the number of records, comma, the number of variables. So we have 150 records and 5 variables. So if we wanted to preview the last few records, here we previewed the first 5. Wanted to preview the last 5, we can use the tail function. So in our case, we would use our first data frame, which is df.tail, and we would get the last 5. So these ones are the last 5 records. Sometimes you would also want to sample your data set because you just want some sort of an unbiased sort of method of just getting a feel of your data set. You can use the sample function to do that, and this will by default will give you just one particular record. But if you wanted, let's say 5, you can do that by giving 5, the value 5 is the parameter to the sample function, and you'll get 5 records which have been sampled through random sampling from the data set. So random sampling we'll also cover in a sampling techniques crash course soon in another course. All right, so we could check the data types of say our data variables, our data frame variables, or our variables by simply using the dtypes property. So this should tell us what data types do our variables have. Like for sepal length, we have floats. Sepal length is this, so we have decimal points, decimal points, decimal points, decimal points. Maybe you might even have this might look like a decimal point, but it might be a string. But it's important to check for data types. That way you don't get an error if you say try to perform a mathematical operation on a string with another numerical variable. So the string data type is usually represented using the object data type, as you can see here. All right, so we've done that. Irrelevant data. So sometimes you might want to drop some data. So as you might get a research question as a data scientist that requires you to only use a subset of the data that you have. Maybe you have all these records over here, but the research question demands that you only use the first two records. The research question might be of between sepal length and sepal width, which one had the flower with the biggest, maybe I would say biggest, maybe not even that. Let me just think of another research question. It might be probably what was the record that had the highest sepal length. Or what was the highest sepal length, or what was the low, what was the minimum or the lowest sepal length. So a research question could demand that, and you would only need just one particular variable. So what you would do, you would need just to delete all those other records or drop them. That's how we usually say. So we would drop those irrelevant columns, and how you would do that is through the use of the drop function. So say we are going to use, we have this new data set, which is data cleaning data set. So we can just import it. I can see that we haven't, this df references the iris data set, but we need to import this. So we can say df is equals to pd dot, then read underscore csv, then df dot head, and just copy this URL into here. Then we should run this to get a preview of the first 5 records, which you can see it's an unclean data set. All right, so this is an unclean data set, but nonetheless, if we wanted to, okay, let me see what we can do about this. I can see it's an unclean data set. So I would need to clean this data set. I'll just quickly, okay, I see what's happening. I'll use a clean data set. I hope there is one here. Just bear with me. Let me just copy it. It's could be, it's actually the same data set. All right, I should have been able to see this. Let me see if I can be able to get a clean data set. All right, I think what I'm going to do is just to use the data set that we had loaded apologies for this. We're going to use the iris dataset, but we're going to drop, let's say, we're going to drop the SIPO width column. So in our case here, what we can be able to do is to load our original dataset. Oops, sorry about that. Oh, let's use this dataset. Sorry about that. Let's use DFCTs. Let's use DFCTs dataset to go about this particular problem. So .head. If you were to load this, just to preview our data set. So we have city, we have all these. So if you wanted to drop the city column, so how we can be able to do this is to use the drop function, and we would pass a list which contains the column that we would want to drop. Then we would use axis to reference the axis that we'd want to drop. So there are two axes. There's the row axis, and there's also the column axis. So x-axis, when x-axis, so not x-axis, then axis is 1. So axis 0 represents a row, and axis 1 represents columns. So in our case here, we would want to reference now the columns. With regards to dropping now the city, so we're dropping the city column, and then we would also pass in place to be true, because we would want to have the original data frame have the changes that we're going to make being reflected. So in this case, if we have it as true, we will be able to replace the new change. So we are going to have a new data frame that doesn't have the city column, and then we can preview that. So if I run this, I need to change the cities, df cities. I should see that we initially, yes, had a city column here, but here we have been able to drop it. If I wanted to drop multiple columns, I could just pass a list that contains multiple column names. So say we wanted to drop latitude and longitude, so we'll use df cities, then latitude and longitude. And if I run this, I'll have only a data frame that has country and temperature. So changing this one as well. All right, so that's it about it. Okay, so now going through duplicates. So sometimes we might have duplicates within our records in a data set, and we might want to delete those duplicates, or we might even want to retain them, or we might even want to identify them, study them, and do something to them later. So for duplicates, we can be able to find them still through by using pandas. First of all, we're going to use a new data frame. So it's called NBA_DF, and if we and this data set, we will first of all read it from this location, then we will preview the shape of it, how many records it has, because we would want to know its size. So it has 458 records and 9 variables. Then we can find or identify which records are duplicate by using the duplicated function. And in addition, once we are able to use the duplicated function to identify those records, we can then use the sum function to find the number of those duplicates. So in our case here, we would want to fetch for records which are duplicated. This is how you are able to fetch for those records, by first referencing the data frame name, then square bracket, then NBA underscore DF duplicated, and we would store the outcome of this in NBA DF. So if I run this, I should have done that. Now, once I have done this, I can then be able to find the number of duplicates. Still, again, through the use of the sum function. So first of all, this will NBA underscore DF will tell me the duplicates, and in our case here, what we stored here were actually those values which are duplicated. So if I run this, I should be able to get the duplicates, which means we don't actually have any sort of duplicates within our data set. Okay, if we wanted to drop the duplicates from our data set, we can be able to do that through the use of the drop duplicates function. So, and nb underscore df dot duplicates would give us now the duplicates. I would actually drop the duplicates, and once they have been dropped, so technically what we are doing here is that we are identifying the duplicates and we are storing them in another variable, which is nba underscore df duplicates, is shown there. So if you run that, we should do that. So our duplicates are contained here. So if I was to preview, I mentioned that we don't have any duplicates. If I do dot shape, or I can do sum, we should be able to not find any records. So in our case, we have 0 records, but n variables. Okay, so what if we wanted to drop duplicates? If we wanted to drop records with a certain column, with a certain column value that is repeated, or it's repeated. So in our case, if we wanted to identify the records with the duplicated with a duplicated country value, then we can be able to pass a list to our duplicated function, and then we store that. Once we have been able to identify those records, we can store them in the duplicates df data frame. And let's preview now how many records we have. Okay, so here it seems we do not. Let's see whether we have nbf. Let's preview this and see whether we have this particular country. So we don't actually have country within our column. This is just to preview our data set, but we don't have country as a column name, hence the error. So what we can do, we could even say, so let's do this. Let's run this. Then run this to just preview our 5 records. Yeah, we don't have country, so we can use something like college. Yep, let's use college. So you can use college. So we'll check for records with a repeated value of college. Running this. I see what could be the problem here. So let's import this date, but if you were to import this data set, you would have a problem because of the problem that we had. Just trying to figure out what could be the problem here. I think I have this data set maybe at the very end. No, I don't have that here. Then our error says college is not part of it. Okay, I see what's happening. It's because we have a different data frame. So here nb_df would need to be what we're actually using a different data frame. So that's usually the problem. So here df, and df is actually referencing another data frame here that we had printed out. I think it's the first. Which one is it? Yes, it's referencing this, and we don't have that. So I think, yes, so this, if we run this, we should be good to go. Good. So so as you can see, we have duplicates, which are quite many, 339, which are repeated. They're quite many. Okay, so yeah, we have quite a number of records which have duplicates with regards to college. What if you can also change maybe to what else? Maybe you could also check the team, but it wouldn't make sense. Well, it may not necessarily make sense with regards to team. Okay, nonetheless, let's continue. So we might also want to drop the duplicates that we found. Say if we wanted to drop those particular duplicates, just going to use the same one. College nba_df and unique df. Okay, this is okay. Then we will get to see how many we will drop the duplicates. Then once we drop the duplicates, we will now determine the size of our new data set. Initially we had 400, I think 400, it was 400 and something, 458, but now we have 119. Quite a big change. Okay, so filtering. Another concept. So sometimes you would want to filter for records with a certain condition. Maybe get records which have a country is equals to 2021, or get a record with a country, probably Kenya or South Sudan, or something of the sort. How you would be able to do that is through now filtering techniques. First of all, let's load our data set that you're going to use and preview it. Then after that, we can now select records where the column has certain values through the is in function. So we would say iris_df, then iris_df dot petal length. Petal length is now the column that we would want to use. Dot is in function, which checks whether this particular value in the list actually exists within that particular petal length column. So if we run this, we should be able to see whether we do have one. Do we? Yes, we actually have 4 of them. Okay, we can select the records where the column doesn't have certain values. So if we wanted to get the column where the records do not have 5.0, we can do so through the use of this particular character. It's usually found, I've forgotten the name of that character, but it's usually found right next to 1 on the keyboard on the top left, just below escape. So this is what we would add. We just need to put that character here, and it would now reference what was not selected with regards, or what does not have the value 5.0. So we can run this and we will get quite a number of records, but pandas will shorten it, 146 of them. Okay, We can select records using filters. So in our case, if we wanted to select records where, let's say, petal width was greater than something, 1.9, we can do so by using, again, the same, almost the same method, only that here we have an operator greater than operator, and so we would say iris df, then reference the petal width. Petal width is this column, is greater than 1.9. Note that in our previous example, we used a dot to reference the column. So this is also possible through the use of square brackets as shown, but you could also do the same thing if there are no spaces between the column names. So you could also do the same thing as that, and you should be able to get the same sort of outcome. So that's another method. All right, so we can also use the query method to get data. Say if we wanted to get where petal width is equals 1.9, we can just use the iris. You can just reference the data frame name, then use the dot query function, well, the query function, and pass the expression that we want to check, and then we use in place to equal to true to replace our new updates, our new outcome, to replace our original data with our new queried data. And once we are done with that, we can just preview our data sets as shown. So you can see petal width has 1.9. We can also perform multiple conditional filtering as shown below. So using still the query method, or the query function. So in our case here we have query, then this is the first condition, SIPO width is equals to 2.7, and we use the and to have an additional condition, and petal width length is equal to 5.1, then in place is equals to true. Then we can run this and we can see whether we have records of such nature, and we have two. SIPO width is 2.7 and petal length is 5.1. So next we can be able to perform sorting to just have our records arranged in ascending or descending order as shown. So we could say iris underscore df. We could use the sort the sort values function, and this we pass to parameters by which column or variable would want to sort the records by and in what way. So ascending is equals to 1, which means that records will be sorted in ascending order, or descending you just need to change this to 0. Let's run this to be able to see that change. Okay, so I think the reason why we have iris underscore df is because here we replaced our original data frame, and our iris underscore df only has 2 values. All right, the last thing that we can do is export data, and we can be able to export our data. So assuming that we had this particular data frame that we have arrived after performing sorting and all of that, and we wanted to use this data set as a baseline for the next say analysis, rather than redoing everything again. Or you could even actually do this, perform this data cleaning and have this data set at the very end and wanted to give it to some other team. You can be able to export your data into a CSV file or in an Excel file. And how we can do that, say on Collab, is first of all we need to import this particular module. It's called Google.Collab from files module, and this will allow us to be able to download our file from Collab. Then once we do that, we can then say, this example will just give us a sample data frame, So assuming this, we're creating a data frame here from this particular dictionary. So our data frame, let me run this, will look like this. Data frame can just be any data set. So this is a data frame, and we can export this particular data frame to a CSV file or in a CSV format through the use of two CSV function. So we would just need to mention you just need to give the name of the file that we would want to have. So, but then after we've done this, we can then download that particular file through the use of the files module that we had imported as shown. So if we run this, we should be able to have it downloaded. Okay, so let me just run this. I forgot to run that. That's the first one, and if I were to now run this, you should be able to do that. So it's downloading. Maybe it might take a few seconds or so. It's going to download like any other file. Sometimes a browser can prevent downloading, so do watch out for that. Maybe prompt that asks you to allow or not to allow your browser to have the website download the file. Okay, so here we exported our data frame in a CSV format. We can also export it in an Excel format as shown through the use of two Excel function. Here we used the two CSV function. You can use two Excel function. Then you pass the name of the function, then download it. So if you run this, you should also be able to get an Excel file downloaded. So this is the one that I was telling you. You'll have a sort of a prompt. So you just say allow for it to download. If you say block, it's going to block, and you need to go to settings with regards to the respective browser that you're using. But the same files are usually stored here. So if you're not able to download them from, if you do not run this particular piece of code, you then need to just go to where they have been exported and just say download and download them. So yeah, so that's a bit about this particular session with regards to data wrangling with Python. Those are just a few concepts that you can learn. However, there are quite a number of them that you might want to go through by yourself. Aside from those ones that we have mentioned, and those other concepts might be how to handle missing data, how to handle outliers, how to perform what are referred as standardization techniques. And yeah, so if you are really interested and a bit more serious about this journey as a data scientist, you can check out the full courses that I'll provide links to in the description box with regards to now data wrangling with Python. So in this particular courses, you will be able to get more topics which will have been covered, or more concepts. In addition, you'll get more examples. I had actually removed some of the topics from this particular notebook, hence the bit of some technicality problems that we had, but nonetheless we're able to go about it. So you'll get more examples and also challenges that you can use to practice and ensure that you have fully grasped the concepts. And there are also solution notebooks which will help you to see whether you have achieved. So if you work on a challenge and you wanted to see whether you worked on it right, you can just check this solution notebook, which will have sample solutions. You can also work on the project. There's also a project within that full course that will allow you to fully grasp the concept that we have covered in this session, and also in that full course session. So be sure to check out that particular link. There will be several links, but you can check out any that you feel works best for you. So if you learned a lot in this video, be sure to check, well, not really check, but to like this video, and also to subscribe to this channel, because I'll be uploading more videos with regards to data science, and that's majorly on crash courses. And also, if you're interested in a live workshop learning experience where we go through 15 workshops with regards to data science, be sure to have a look at the AfterWork Data Science Fellowship Program. I'll also be taking you in a live environment with regards to data science. And last but not least, if you have any questions, you could always join the AfterWork Data Science community in the Telegram link that I'll link down there, and and ask questions while you're there. That way you are able to get a community also helping you out on your learning journey. So that's about it, and see you in the next crash course, which I'll be uploading in a few days time.